So hello and very good evening to all of you. Welcome to Resultant AJ YouTube channel. I'm Vikash Sir and I welcome you all to this new series that we are going to start today, which is Practice Power Hour. So in this series, we are going to basically practice some important questions on my subjects, basically that I teach, thermodynamics, IC engine, refrigeration, power plant, fluid mechanics. Today we are going to solve the questions on subject of thermodynamics. I hope my audio and video is fine. Please just let me know if my audio and video is fine or not. Yes. So good evening everyone. Please confirm me about the audio and video. Yeah. So good evening everyone. Welcome to the session. We are meeting after a long time. I think the last class, my last class was on Wednesday in the previous week, and I have taken 3 sessions in the last week. I hope you guys have seen those sessions and just comment me. I just want to see your comment. Yeah, Ramjeevan, good evening. Welcome to the session. So good evening, everyone. And so the last class that we had in the last previous week, till from then, you guys must have celebrated Independence Day, and today was Raksha Bandhan. So many of you must have. Those who are with their family must have celebrated Raksha Bandhan also. So happy Raksha Bandhan to everyone. So guys, as you know that today is thermodynamics power hour and we are going to practice some important questions on subject of thermodynamics. Just reply me in the comment box. Just answer me in the comment box if my audio and video is fine or not. Yes. Please tell me. Is my audio video fine? So if my audio and video is fine, then do not forget to like the session, share the session, and if you have joined this YouTube channel and not subscribe the channel yet, please do not forget to subscribe the channel and press the bell icon, which is just near to the subscribe option. Okay. So good evening everyone. Good evening Sujan. Welcome to the session. Sujan Singh. So currently I can see only 2 students live in the session, but I hope that with time, as a session will go on, many of other students will also join the session. So my dear students, let me introduce myself to you guys. Those who are meeting me for the first time, my name is Vikash Sir and I'm a faculty of mechanical engineering having more than 7-year teaching experience. I have done my MTech in thermal engineering from Thapar University, of course, through a GATE examination. That means I have qualified GATE examination, and not just once but multiple times. That I don't think is required here to be mentioned, but I have mentored more than lakhs of students for different exams like GATE, engineering services, SSC, JE and other AJ exams. These are the subjects that I generally teach: fluid mechanics and thermodynamics, applied thermodynamics. Coming to the first question, I will not make you wait guys, because I know that so sir, सब तो session English to English होता है. Yeah, English to English है. Yes, Sujan. The session is in English right now, and if you are having any problem in anything, you can just let me know. The time taken by system to execute a process through a finite gradient is infinitely large, then the process will be called as. Time taken by a system to execute a process is infinitely large time. That means it's a very slow process. It's a slow process. It's taking a lot of time. It's taking infinitely large time. It's a slow process, and slow process are generally they are reversible process. Okay, slow process are reversible process. So here the answer will be, it will become reversible process. Option A will be the answer. ऐसा क्यों? Because the main reason why we are taking the classes in English is most of the students in whole India, I think there are some regional languages also, but I think if you go across any state of the country, you will find that English is a language which is being taught in all the schools, and I think everybody understand that. So the main reason for starting these classes in English is this, so that everybody can attend the session. But I think the response is not good right now, because it's a new channel, and you can see the subscribers are also very less. So if you think that only 5 students are watching, that means that's because I'm speaking in English. That's not the reason, because I think it's a new channel. Many of the students are not informed about this channel. Okay. So as the time will proceed, more students will come to know about this. They will be able to know that this is a YouTube channel where we teach in English. So maybe students who need the classes in English, they can attend the classes. Okay. A heat pump is used to heat a house in the winter and then reversed to cool the house in the summer. The inside temperature of the house is to be maintained at 20 degrees Celsius. The heat transfer to the house wall is 7.9 kilojoule per second, and the outside temperature in the winter is 5 degrees Celsius. What is the minimum power consumption required to drive the heat pump? Yeah, that's the reason that we are taking the classes in English, so that every student can understand. Now see this question. There is a heat pump which is required to heat the house in winter, and with the help of reverse technology, you can also cool the same house in summer. So what are the conditions of temperature mentioned in this question? The conditions are, the house is to be maintained at 20 degrees Celsius. That is, high temperature will be 20, and the lower temperature is how much? The lower temperature is 5 degrees Celsius, which is the outside temperature. In this particular question, it is being asked, what is the power input? What is the power input that the heat pump will need? Okay. Yeah, Bose sir. Okay, you are asking about Bose sir. Bose sir is, I think, if you don't know, Sujan, he has joined Indian Railways. Okay, he has got selected Indian Railways as a JE. So that is why he is not into teaching right now. So the heat transferred through the house wall. So this is your house, which is to be maintained at 20 degrees Celsius. Okay, this is a house to be maintained at 20 degrees Celsius. Okay, and this is the outside temperature. This is the outside temperature. Please try to understand the question. It's a good question. Outside temperature is 5. House is to be maintained at 20. Now heat transfer to the house is how much? How much is the heat transfer to the house? That is equal to 7.9 kilojoule per second. This is the heat transfer to the house, so that the house can be maintained at 20 degrees Celsius. So firstly, what we will do, we will find the COP of the heat pump. COP of the heat pump will be equal to how much? It will be high temperature over high temperature minus low temperature. Okay, clear? So just try to solve it, and just give me 1 second and try to solve it. Just give me 1 second. Yeah, please everyone try to solve this question. Yeah, yes guys, I need to, I need this space so that I can solve this question. So I have to hide my video. So this high temperature is 293 Kelvin divided by 20 minus 5, that is 15. So you can find the COP from here. Now this COP is equal to desired effect. What is the formula for COP? Desired effect divided by power input. Okay. In this particular question, the desired effect is given already, 7.9 kilojoule per second. But since the answer is required in watt, you can see, and watt is joule per second. So this will be 7.9 into 1000 watt divided by power input. COP you can find from here. What is the COP you are getting? 19.53. Yes. It's 293 divided by 15. You will get 19.53 COP. Just put the COP here and you can get the power input. So that will be 7900 divided by 19.53. 404 point something. Just a second. Yeah, it will be just, sorry. The power input will come out to be 404.5 watt. So the answer will be option B in this case. Okay. Are you all getting this value? Please tell me. Next question. Next question. Try to solve this question. Just a second. Yeah. A system while undergoing a cycle A to B, then B to C, then C to D, then finally to A. That means it's a cycle. What is the meaning of a cycle? That means the process, you are starting a process from A, okay? Point A, you are starting a process and you are ending at point A. That means the point from which you have started, you are ending at the same point. That means it's a cycle. A cycle is formed from A to B, then B to C. And this cycle is consisting of how many processes? 4 processes. A to B, then B to C, then C to D, then finally D to A. So there are 4 processes in this cycle. Okay, clear? And in each process, the heat transfer and work transfer are given in the question. It is mentioned in the question. You have to find the power developed in kilowatt. What is the power developed in kilowatt? Hi Subhadeep, good evening, welcome to a session. So power developed will be equal to, no, you have to find the power developed. So it is very simple. So power you can find from this data, right? Where is the data given for power? The work is given, and right. So total work will be equal to, net work will be equal to what? Net work will be equal to 474 minus 180. This will be net work. 294 kilojoule per minute. 294 kilojoule per minute will be the value of the net work, but you don't have to find the net work, you have to find the net power. Okay, so you have to find in kilowatt divided by 60. If you divide by 60, you will get 4.9 kilowatt. So this will be the value of net power. Clear? It's a simple question, not that complicated. And Subhadeep, you are writing net work by heat supply. If you do that, you will get efficiency. Okay, that means if you add the heat supply will be this data. What is the heat supply? This plus 687 and plus 75. So if you want to find the efficiency by using this data, then efficiency will come out to be net work divided by heat supplied. The heat supplied will be, net work you all know, it is 294, heat supplied will be 687 plus 75. So this will give you efficiency. Okay, so that is how you will get the efficiency, but in this case you don't have to find the efficiency, you have to get the net power, and that will be 4.9 kilowatt. Clear? Next question. Which of the following sets of thermodynamics law is directly involved in determining the final properties during an adiabatic mixing process? इसलिए आंसर नहीं आ रहा. That's a problem. Read the question carefully. It is being asked to find the power, you're finding the efficiency. That means that's something that you are doing wrong, right? Final properties during adiabatic mixing. Mixing is a process where two types of, let's say two types of fluids. This is fluid number 1 and this is fluid number 2. They both are getting mixed. But it is of adiabatic mixing. This is fluid number 3, which is the final mixture. So they are getting mixed. In this particular case, when they are getting mixed and it is a kind of adiabatic mixing process, then which two laws will be required? First and second law of thermodynamics will be required to get the final properties. What are the final properties? Let's say the final properties are, obviously it is not the mass we are talking about. Let's say we have to find the enthalpy, final enthalpy. We have to find the internal energy. We have to find the final temperature. So how you will get these properties? Which law will be applied? Tell me everyone. Which law will be applied in this case to get these final properties? Any idea? Have you seen this question before? Yeah, I have taught you from a very long time. We must have discussed this question. Adiabatic mixing process, that means we are not using the, there is no heat transfer. Okay. So second law of thermodynamics will be required in the adiabatic mixing process. But apart from that, which is also required here? Yes. One will be second law of thermodynamics and the other will be obviously the first law of thermodynamics, because mixing process taking place. Let's say two fluids are getting mixed. So one will be losing heat, one will be gaining heat. So first and second law of thermodynamics, they will be required to get the final properties. So correct answer will be option number A. Clear? Yeah. So it is first and second law of thermodynamics that is required. Next question is, consider the following statement in respect of axial flow air compressor. And axial flow air compressor is often described as a, sorry, how we are getting this question of axial flow compression? Oh, it is a question of power plant. No problem, let's solve this question. We are, maybe by mistake I have got this question. So axial flow compressor is often described as a reverse reaction turbine. The axial flow compressor and turbine and compressor are two different things. Turbine gives you work output, compressor takes work input. So how these, it is called as reverse reaction turbine, because axial flow compressor, if you compare the reaction turbine, and if you compare the axial flow compressor, wow, so many interested students. Axial flow compression, reaction turbine, if you compare, in reaction turbine what you get is, just a second, you get fixed blade and moving blade. Okay, here also you have fixed blade and moving blade. Okay, but difference is that this is a work input device, this is a work output device. Okay, and in fixed blade and moving blade of axial flow compressor, what happens in fixed blade, what happens, pressure will increase and velocity will increase. In moving blade of axial flow compressor, only pressure will increase, velocity will decrease. While in the case of reaction turbine, in fixed blade, pressure decreases and velocity increases. In moving blade, what happens? Pressure will decrease and velocity will also decrease. So in somewhat, it is a reaction turbine. Axial flow air compressor is often described as reverse reaction turbine, because the reverse thing happens as compared to reaction turbine, and with 50% degree of reaction. You know what is a 50% reaction turbine? 50% reaction turbine is Parsons turbine. Parsons reaction turbine is a 50% reaction turbine. When it becomes 50%, when degree of reaction becomes 50%, that means velocity diagrams are symmetrical. So both the statement 1 and 2 are correct. Okay, both statements are correct. Next question, try to solve this question while I am just going to connect my charger. Try to solve this question. Yes, everyone. See, I hope you guys remember we have solved these kind of questions. It's a very simple question. System undergoes a change of state during which 100 kJ of heat is transferred to it and it does 50 kJ of work. System is brought back to its original state. Now, when system is brought back to original state, that means you are changing the state of a system, let's say from 1 to 2, and you are bringing back the system to original state. Original state is this. This is the initial state. Initial state. So you are bringing the system to same initial state, right? That means it is a cycle. A cycle is formed. And for a cycle, we'll apply the first law of thermodynamics. Net heat transfer is equal to net work transfer. This is first law of thermodynamics. Simple first law of thermodynamics. So apply the first law of thermodynamics for a cycle. Net heat transfer will be Q1 to 2 plus Q2 to 1. Net work transfer will be W1 to 2 plus W2 to 1. Just put these values, you will get the answer. Heat transfer from 1 to 2 is a system undergoes a change of state during which 100 kJ of heat is transferred to it. So 100 kJ of heat is supplied, right? And it does 50 kJ of work. So in the first process from 1 to 2, the system is doing 150 kJ of work. It is doing the work, that means it's a positive work. Heat is transferred to it, that means it's a positive heat, right? System is brought back to original state through a process during which 120 kJ of heat is transferred. So in this process, 120 kJ of heat is transferred. That means it is supplied. You have to find this work. Simple calculation. You will get 170. If you solve this, you will get 170. Okay. Next question. Two Carnot engines are operated in series. The first one, which is Carnot engine A, receives heat at temperature of 650 Kelvin and rejects heat to a reservoir at temperature T2. The second engine B receives heat rejected by the first engine and in turn rejects heat to a heat reservoir at temperature T3 is equal to 300. Calculate the temperature T2 if work output of the two engines are equal. So we have discussed this thing. If Carnot engine are kept in series, then what we have to do, in that case, the intermediate temperature will be, and also if work output becomes equal, then intermediate temperature will be just arithmetic mean. This is called arithmetic mean of these temperature, extreme temperature. So you have to just do an arithmetic mean, right? 650 plus 300 divided by 2. So you will get 475 Kelvin. Option D will be the right answer. Clear? Yes, good. Subhadeep, Ramjeevan, very good. The right answer is option D. Next question. Consider the following heat interaction in process. Which of the following statements are correct? So there are some things mentioned about the heat interaction and there are some statement given. You have to tell which of the following statement is correct. Heat transferred in isochoric. What is the meaning of isochoric? Constant volume is same as the work done. So that is not the case for isochoric process. That is for isothermal. For constant temperature process, we can say that heat transfer is equal to work, but not for the isochoric. So this is the wrong statement. Heat transfer at constant volume is equal to change in enthalpy, which is not correct. Heat transfer at constant volume is equal to change in internal energy, not enthalpy. So this is also not correct. Heat interaction in the polytropic process is less than the work. Heat interaction in the polytropic is less than the work. Yes, this is correct. In polytropic process, the heat transfer is equal to work of the polytropic process into gamma minus n over gamma minus 1. This is a formula, and according to this particular formula, we can say that if you see, you know this thing that gamma is always greater than n. Gamma is the adiabatic index which is always greater than n. And with this formula, we can say that, we can confidently say that in case of polytropic process, work transfer will always be greater than the heat transfer, right? So that is why option Z is the right answer. As per the Charles law, the volume of a given mass of a perfect gas varies dash as its absolute temperature when the absolute pressure remains constant. Charles law talks about pressure being constant. So at constant pressure, obviously the volume is directly proportional to temperature. So volume varies as directly as absolute temperature. Okay. Next question. A Carnot power cycle works between 27 and 127 degrees Celsius. What is the work done during the isentropic expansion process? Isentropic expansion process, work done you have to find. So how you will solve this question? Carnot power cycle. Carnot power cycle, you can draw it on temperature entropy diagram also, and you can draw it on pressure volume diagram also. So let's say right now we are because temperatures are given, so let's draw temperature entropy diagram. So it's kind of this is how the shape of a Carnot cycle is. Okay. On temperature entropy diagram, it contains two constant temperature process during which heat is applied and rejected, and two isentropic process during which work is done and work input and work out. So this is expansion process, this is expansion process, and heat is supplied at constant temperature. Here heat is rejected, constant temperature. In this question, the temperature are given. This is the temperature. High temperature is 127 degrees Celsius and the low temperature is 27 degrees Celsius. You have to find the work output in this question during isentropic expansion. So 2 to 3 is isentropic process. It is an isentropic expansion process, right? So for this process 2 to 3, because isentropic process means heat transfer is equal to 0. You can say, you can ask why? Because isentropic means reversible adiabatic, and adiabatic means heat transfer is 0, right? So we know that first law of thermodynamics, Q is equal to W plus du. If heat transfer is 0, then work will be equal to minus of du, that is minus of m Cv T2 minus T3, sorry, T3 minus T2. So you can say work will be equal to mCv T2 minus T3. Mass is given to Cv is equal to 0.7, T2 is equal to high temperature, this is T2, 127 minus 27. Just solve it, you will get the answer. Okay, it will be 140 kilojoule. This will be the value of work. Clear to everyone? Hello Kuldeep, good evening, welcome to a session. All right, next question. A storage battery having a terminal potential of 8.5 volt draws a current of 8 ampere for 3 hours. If the stored energy of the battery is decreased by 1200 kilojoule, then evaluate the energy stored, evaluate the heat interaction across the boundary enveloping the storage battery. So we have a storage battery. Obviously, the battery will store power or electrical energy, right? This battery is receiving the voltage which is having equal, it is equal to 8.5 volt, and the current which it is drawing is equal to 8 ampere current. Time is equal to 3 hours. Okay. Now, in this question, let's say across this battery we have a surrounding. You have to tell what is the heat transfer. Also, it is being mentioned in this question that the stored energy is decreased by 1200. What is stored energy? You all know that stored energy is internal energy. It is getting decreased. It is equal to internal energy, which is equal to minus 1200 kilojoule. It is getting decreased, right? All I can see are all the known students, Subhadeep, Kuldeep, Ramjivan. Now, work input is given in this question is, work is equal to what? It is voltage into current into time. This is work. Voltage is equal to 8.5, current is equal to 8, time is equal to 3 hours. Because it is 3 hours, so 1 hour is equal to what? If you multiply with 3600, you will get the total work in kilojoule, work input. Just solve the answer. What is the value of work input in kilojoule? You can use a calculator also. So when you solve it, you will get 734.4 kilojoule. Okay, work input. Because it's a work input, it will also minus. So you can apply Q is equal to W plus DU. Work will be equal to minus 734.4. But here you don't have to take the sign. I think it will be, work will be taken as positive, minus 1200. Solve it, you will get the answer. What is the value you are getting? It will be 465. It is minus 465.6. You know what? Why we have taken work as positive? The reason is that if you take work input negative, so you are not getting any options. All the options are less than, the answer. If you add these two values, it will be around 1900 something, but it is not coming. So work has to be negative. The reason we are taking it as positive is the formula is Q minus W is equal to DU. So it will be Q minus of minus 734.4 is equal to DU, which is minus 1200. Anyways, we have to get the answer. So we have to take any one of them has to be taken positive. So internal energy is decreasing, you have to take minus. Work is input, we have to take minus. But if you take both minus, you will not get the right answer. So that is why we have to take either of them as minus. Also, the reason is very simple. The heat will be minus. Heat will come out to be negative because heat is rejected. Heat will get rejected from the battery. So this will be minus, that is for sure. Okay. So the answer will be option A. Next, which of the following parameter is constant for a mole for most of the gases at a given temperature and pressure? Yes, everyone. For a mole, which is the following parameter which is constant for a given mole for given temperature and pressure? That means if pressure and temperature are kept same, then for given mole, mole means amount of substance. For given mole amount of substance, which will be constant? Which is the parameter will be constant? That parameter will be volume. Why? Yeah, it is very good. It's good. Avogadro law. Correct, Subhadeep. The answer is option B, volume. Because according to Avogadro's law, for same pressure and temperature, if pressure and temperature of the gas is kept same, then volume of the gas molecule is directly related to the number of moles. So if mole is constant, then volume will also be constant. Okay. The internal energy of a gas obeying the van der Waals law. Van der Waals law is P plus A by V square into V minus B is equal to RT. This is van der Waals law. Okay, it is real gas equation, van der Waals equation. And for this real gas, you have to tell internal energy depends on what parameters. Now we know that for ideal gas, we all know that if it have been ideal gas, if it would have been ideal gas, then internal energy is a function of only temperature. That we all know that we all know, right? But what about the real gas? For a real gas, the internal energy is not just a function of temperature, but it also depends on volume, that is specific volume. The answer will be option C, both temperature and specific volume. Okay. 100% efficiency of a thermal cycle cannot be achieved because of. Why can't we achieve 100% efficiency of a thermal cycle? That is, like for a heat engine, you cannot have 100% efficiency. Why? Efficiency of any thermal cycle is equal to 1 minus heat rejected by heat supplied, or it is equal to net work divided by heat supplied. But why can't we have this efficiency equal to 100%? Tell me. And this is the efficiency of any cycle. Let us talk about the Carnot cycle, which you say it is a reversible one, right? So if we say Carnot cycle also, it is a reversible cycle. Its efficiency depends on temperature. So can we have efficiency of Carnot cycle equal to 100? No. Why? Because if you want to make Carnot cycle efficiency 100, you have to make lower temperature equal to 0 Kelvin. But we all know that 0 Kelvin is not possible. So even for a reversible cycle, we cannot have 0 Kelvin. Since we cannot have 0 Kelvin temperature according to third law, so we cannot have 100% efficiency also. Okay, even for a reversible one. Forget about this normal cycle. Let's talk about the Carnot cycle. Carnot cycle is a reversible cycle. So even for a reversible cycle, we cannot achieve 100% efficiency. That means we cannot have 100% efficiency even for Carnot cycle, right? Because in order to have 100% efficiency for a Carnot cycle, which is a reversible one, the lower temperature has to be 0 Kelvin. But 0 Kelvin is not possible according to third law of thermodynamics. So having efficiency 100% will not just violate second law, but also third law. Okay, getting the point? It will violate both thermodynamics second and third law. 0 Kelvin temperature is not possible. 1 kg of air having R is equal to 287 joule per kg Kelvin goes through an irreversible process between two equilibrium state. You can see this equilibrium state. What is the change in entropy in joule per kg Kelvin? It's very simple question. The two states are given. Initial state temperature is 30 degrees Celsius and volume is equal to 1.2 meter cube. And final state temperature is equal to 30. That is, temperature is same in both the cases. Volume is changing, right? Because it is a case of you have to find the entropy change, and you know the relation of entropy. You can say that in terms of temperature volume, you know the relation, it is Cv log T2 by T1 plus R log V2 by V1. You want to keep mass here, you can also keep mass, multiply by mass m, okay, mr. Okay, so because T1 is equal to T2, we can say this will be 0 because log 1 is equal to 0. So entropy change will be simply equal to m, which is 1 into R is 287 log of T2, sorry, V2 is equal to 0.8 by 1.2. You all have calculator, use your calculator and give me the answer. It is very obvious the answer will be negative, so the answer will come out to be minus 116.36. Are you getting option A? Okay. Increase in entropy of a system represents increase in available energy, increase in temperature, decrease in pressure, or degradation of energy. If the entropy is increasing, that means obviously your energy, the total energy is degrading. Total energy is composed of two things. It can be either converted into available energy, which is also called as exergy, or you can convert it into unavailable energy, or it will be converted into unavailable energy. So basically total energy can only transform in any of these two energies. Available energy is the total maximum work that you can obtain when in an ideal case the maximum work that you can obtain is available energy or exergy, and unavailable energy is nothing but irreversibility. So if you have to do a process in which your entropy is increasing, that means your total energy is entropy is increasing, that means this is increasing, this is increasing, that means this is not decreasing, but this is total energy is constant. Just see this, total energy is constant. If unavailable energy will increase because of increase of entropy, then this will decrease. If this will decrease, that means this is not decreasing, but this is degrading. Degrading means loss of quality. Loss of quality in something. Degradation is not related to quantity, it is related to quality. Are you getting a point, everyone? So quality will degrade. Degradation means, like we say, when we have fresh vegetables. Okay, when everybody wants to have fresh vegetables and want to consume fresh vegetables or fresh fruits, but after keeping these vegetable fruits for one day or almost 1 week, or maybe after 15 days, they will definitely they will be degraded. That means they will not be of that quality that we get fresh. That quality will be in the fresh vegetable or fruits. So degradation means loss in the quality of something. So that means if entropy will increase, unavailable energy will increase, available energy will decrease, and total energy will not be decreasing, but its quality will decrease. Okay. In a process, the final pressure and volume of a fixed mass of an ideal gas are twice that of its initial pressure volume. If the initial temperature of the gas is 27, then final temperature in degrees Celsius will be. Sir, please start poll-based class topic wise. Subhadeep, poll-based classes are not possible here because in our generally we take the classes in YouTube, and in YouTube this poll-based option is not possible. Okay, here in this YouTube channel. The final pressure and volume of a fixed gas. But if you are forgetting things, then I must suggest you, if you try to keep attending the classes. Right now we are basically providing you practice sessions, but very soon, depending on the examination, as soon as some examination will come, we'll also provide you some revision classes also in the YouTube only. Okay, so just don't worry. Okay, if you are forgetting the concept of any subject, whether it is thermodynamics or IC engine, refrigeration, power plant, fluid mechanics, these are my subject. But if I'm talking about the other subjects also which are being taught by other faculties, then we'll surely come with some revision classes also. Okay, don't worry, in the YouTube. So fixed mass. See, one thing is same, that is mass is constant. Mass is fixed. The final pressure and volume of a fixed mass are twice. The final pressure is twice of initial pressure. Final volume is twice of initial volume. Initial temperature is 27. And we are talking about an ideal gas, right? For ideal gas, we all know that for an ideal gas, PV is equal to MRT. This is ideal gas equation. And we can also say PV by RT is equal to M, that is mass. Since mass is kept constant, so, and the gas is changing its state from 1 to 2, right? Final initial to final state of pressure volume. So we can also say that for given mass of a gas, changing state from 1 to 2, we can apply this equation. P1 V1 by RT1 is equal to P2 into V2 by RT2. Because gas is same, so R will be same, so this will get cancelled out. And we can say from here that T2 will be equal to T1 into P2 by P1 into V2 by V1. You supply this, so you will get T1 is equal to 27, that is 300 Kelvin into 2 into 2. So this will be 1200 Kelvin. So answer will be 1200 Kelvin. The final temperature will come out to be 1200 Kelvin, not degree Celsius. But they are asking the answer in degree Celsius. So please find the answer in degree Celsius. Yes. 1200 Kelvin you are getting here. In degree Celsius, that will be 927 degrees Celsius, not this. So in a hurry, I think many of you may mark answer option D as the answer, but please note down this thing that they are interested to get the answer in degree Celsius. They want the answer in degree Celsius, not Kelvin. Okay. So if by mistake, if you are in a hurry and you don't see this thing that in the question they are asking to find the answer, the final temperature in degree Celsius, not Kelvin, and if you just in a hurry just mark option D as the answer, then after the exam will be over and you will see the response sheet, then you just do this, right? After seeing the response sheet, that what kind of mistake I have done. Okay, so please read the question carefully. I think this is we have done. If a graph is plotted for absolute temperature as a function of entropy, if a graph is plotted for absolute temperature as a function of entropy like this, then the area under the curve would give area under the curve. Let's say this is a curve, okay, a constant temperature process on temperature entropy diagram. So area under the curve gives you what? Tell me. This area will give you what? See, area under the curve will give you either the heat supplied or it can give you the heat rejected also. But by default, we always take heat supplied. We never say rejected. We never initially talk about negative things. So let's say that the heat is supplied, the work is being done, the process done from left side to right side, which is a heat transfer process, and heat is being supplied. Okay. So amount of heat supplied will represent, you know that Q is equal to TdS. For a reversible process, area under the curve gives you heat supplied, not the work, not the mass. It gives you heat supply, and that will be heat supplied, of course. During an adiabatic process, the pressure P of a fixed mass of an ideal gas changes by delta P and volume by delta V. Then value of delta V by V is given by. It's a very simple question, but I think most of you may need some time because you have to do some derivation stuff. Equation of an adiabatic process. For adiabatic process, the equation is PV power gamma is equal to constant. I don't know how many of you have studied. I think everybody has studied mathematics in their class 12th and must have studied differentiation. If you differentiate both sides, you will get P gamma weak power gamma minus 1 dV. This is called product rule, right? Plus, now we'll keep V की power gamma as constant, and this will be differentiation dP, and constant differentiation is equal to 0. Now if you solve this, it will be gamma P weak power gamma minus 1 dV plus weak power gamma dP is equal to 0. Just try to solve this thing, okay? What you will get? In this question, what you want from this question? You need to get dV by V. Just put dV by V this side, which is delta V by V, and all the other parameters have to be kept on the other side. But it will take some time. dV by V will not be. Yeah. So this will be gamma into P dV, let's say, is equal to minus V की power gamma dP over V की power gamma minus 1. Try to solve this thing. You will get gamma P dV is equal to minus V की power gamma. V की power gamma is equal to what? And this will come in the numerator. This will be minus gamma plus 1 into dP. This will get cancelled out. Okay, so this will be, let me just hide myself. gamma into P dV is equal to minus V dP. So solving this thing, you want what? You in this case you want dV by V, right? So dV by V will come out to be what? Minus dP by gamma P. Okay, are you all getting this? Clear to everyone? So here I think there is some mistake in the options given. Either this is not correct, this is not correct, and this is positive value given, and this has to be in the numerator. This minus is there, but this has to be in the numerator. Then only this will be the answer, correct answer. Okay, sorry, denominator. Clear to everyone? Next question. See, the reason I am trying to take all the types of questions in these sessions, because if I take only easy questions, then you will those easy questions may not always come in the exam. Okay, and the objective of this session is to make you practice. We can practice all the types of questions, right? Because in the exam we cannot we cannot expect that only easy question will come. Okay, questions level can be like, as you know that if you are preparing for RRB JE CBD2, the questions level can be where calculator is required for numerical part. For theory part also, questions will be little bit logical, right? These kind of derivative type questions. In a polytropic process, which of the following equation will be used? We know that for polytropic process, we all know the equation. I hope you remember the equation for polytropic process. It is T2 by T1 is equal to V1 by V2 power n minus 1, right? But here they are not asking T2 by T1. If they ask you T1 by T2, then what will happen? So if it will be T1 by T2, it will just become V2 by V1. Simple. Nothing will change. This will become V2 by V1 n minus 1. Okay. One more relation we know for polytropic process, and that is P1 V1 की power n is equal to P2 V2 की power n. Okay, clear? So V2 by V1 की power n, in this case V2 by V1 की power n is equal to P1 by P2. Okay, it will be P1 by P2, because we need to get, oh wow, sorry, this is one relation, and then we have one more relation, that is T2 by T1 is equal to P2 by P1 n minus 1 by n. This is in terms of temperature and pressure. So if you have to get the answer in T1 by T2, it will become P1 by P2 n minus 1 by n. Okay, but as you can see, none of the options given here are matching to this. There is definitely some mistake. Some mistake in the typing, I guess. This is not correct. These two options are exactly same. Yeah, they are exactly same. This will be either of the option will be this n minus 1 by n. Okay, let us take it as n minus 1 by n, then this will be the right answer. Okay, clear? What is the temperature at which a system goes under a reversible isothermal process without heat transfer? I think we have discussed this type of question. Constant temperature process and no heat transfer. This is only possible. These two conditions are only possible if you have absolute zero temperature at 0 Kelvin temperature, which is absolute temperature. Absolute means 0, that means Kelvin temperature, and 0 means 0 Kelvin temperature. At 0 Kelvin temperature, we can confidently say that the temperature will be constant, heat transfer will be 0. But these two conditions are only possible at 0 Kelvin. The air is expanding from a very minute hole of cycle tube. So we have a bicycle tube, and from that bicycle tube we have a cycle tube. Okay, and this is a cycle tube, and from that cycle tube a small hole is there, a puncture is there basically, and the gas is basically getting leaked from the cycle tube. Okay, and we have a very small hole, and from this hole the air is escaping from this hole. So because it's a very small hole, and the air is passing from this hole, this process will be called as throttling process. This is a throttling, and for this throttling process we all know what will be happening to the work. The work done will be 0. Okay, example of throttling is minute hole. Okay, flow of fluid through small aperture. Small aperture means small hole. If the fluid is flowing through small hole, aperture means hole, it is called as throttling, not free expansion. Many of you get confused between throttling and free expansion. Let me tell you, okay, yeah, sorry. So this is throttling, okay? But if it is an evacuated room, that means now this is a case of free expansion. If it is evacuated room, that means evacuated room means there is no gas around. That means it is a vacuum all around. So if the gas is expanding into vacuum, now this will become free expansion. Okay, so it is a basically combined case. We can say it is a small hole and it is also happening in vacuum, so that it is a case of throttling, and also it becomes free expansion. Okay, anyways the work will be 0, because in both the cases, whether it is throttling or whether it is free expansion, in free expansion it is flow of gas into vacuum through large hole, through large aperture. From a large aperture, if the gas is flowing into vacuum, that is free expansion. But if it is through a small hole, it is throttling. But in any case, in both the cases, the work transfer is 0. For work transfer is 0 for throttling also, and it is 0 for free expansion also. The next question is also the last question of today's session. An inventor states that the new engine he invented rejects 30% of the heat it absorbs from the reservoir, while the temperature of the source and the sink are maintained at 500 and 200 Kelvin. This engine is equivalent to. So this inventor has invented an engine which is rejecting how much heat? It is rejecting the heat which is 30% of the heat it absorbs. Absorb means heat supplied. So we can easily get the efficiency of this engine which is invented by the inventor. So that will be equal to 1 minus heat rejected by heat supplied, which will be 70%, right? But this is the efficiency of the engine which he invented. But is this engine possible? So that can be checked with the help of Carnot cycle efficiency. So Carnot cycle engine efficiency will be 1 minus lower temperature by higher temperature, which will be 1 minus 200 by 500, which will be how much? Which will be 60%. So you can see that the inventor has, this is the engine invented by inventor. The engine invented by the invented engine efficiency is greater than Carnot engine efficiency. Is it possible that you are inventing an engine and its efficiency is coming out to be greater than Carnot? That is not possible. That is impossible case. So the answer will be option C. Clear? So that's all, my friends, and the rest of the question will be taken care of in the upcoming sessions. But let me tell you that if you have not liked the session and shared the session plan, then please do it, so that more and more students can come to know about this new YouTube channel. See, this is a new YouTube channel, and many of the students are not informed about this. So that's why we need to get more subscribers. We need to have more students joining our YouTube channel so that more students can be get informed about this and they can take the benefit of these classes. Tomorrow, my friends, we are going to practice questions on IC engine and automobile. IC engine and automobile is also important subject if you see RRB JE point of view, and for SSC JE point of view it is also important, as in SSC JE from IC engine you can expect 20 questions at least. So IC engine automobile, it is important for if you see the syllabus of RRB JE, it is important for both RRB and SSC JE CBT2. So that is why we are going to practice the question tomorrow 8 p.m. on this YouTube channel for on this IC engine and automobile. So timing will be 8 p.m. Thank you so much. If you have enjoyed the session, then do not forget to like and share the session. And please, if you are new to this YouTube channel and not subscribed the channel yet, then please do subscribe the channel. Thank you so much. Have a nice day. Thank you. Take care.